Okay, so we have some announcements because of the snow day shenanigans. Um, First thing is someone set up a Slack channel. There's a pretty active Slack channel, so if you use Slack and you have a question, uh, mention me and it'll notify me and I'll go and check it. If it's a question that anyone can answer, you don't have to tag me. I'll eventually look at it. But if you don't want to use D2L, or if you find using Slack is easier, I'm on both. Yeah.
Do we have an IRC integration with Slack?
I don't think so. But since someone created this and pointed me to it, so the IRC is difficult for. Well, no, I guess I could install that. But yeah, I would prefer not too many modes. So this is your one sort of semi-real-time mode. The D2L forum is also I don't get notifications on D2L. I pull that. So if it's urgent, maybe you can use Slack. I see the benefit of using Slack is that there's this CS help channel as well. So I don't know. I haven't been on it enough to know how much traffic goes through there. But if this is the thing that you guys are using, I'm more than happy to get on it. It kind of depends.
Depends on the class.
Are the tutors on there at all, or no?
Yes, the tutors are on.
Okay, so because a lot of times you'll be stuck at home because of the snow, and then you'll have a question, and then that will be your way of trying to get it in real time. Okay. There's been a lot of discussions on D2L, though. There's been a really good set of questions and answers on D2L. So if you're struggling with the programs or any of the lecture material, definitely scan that, because a lot of those questions that you might have are probably being asked on that forum and being answered with code, even in some cases. So you definitely want to be looking at that. Because of the snow day, and if you guys have been checking email or on D2L, you know I've been hosting virtual classes, so screencasts. I want to take a minute to talk about what's out there. So the first 1A, 1B, and 1C, you were in class here live for. 1D, I recorded on that first snow day, and this is finishing up the C programming language. So I intended you to watch that on Thursday, and if you haven't, go back and watch this. This one, and then the next lecture to both the C library and the Make GDB one. Those were for your programming assignment for today. So hopefully you were able to go through both of those, and there was enough information there for you to actually create a make file, figure out how to use a debugger. Although some of you probably didn't use the debugger, that's okay. I'll get you with the debugger in your homework eventually. You'll be intimate with GDB by the end of this quarter. And then, so that actually, Thursday was meant to be this piece, and this piece. And then the Tuesday lecture is the system organization one. And these are actually lectures that I did last quarter, but I had them around, so I didn't have to re-record all of them. But this pretty much covers what I wanted to cover on those snow days. So again, if you didn't check your email, or if you weren't on D2L to see this, go back and watch these things to catch up. And so I had also posted, I was going to take any questions that you might have. For those who did watch it, were there things that were in the videos that you didn't understand, any concepts? So the problem with distance learning is that there's no interaction. I can't answer questions as you have them. So I had sort of asked you to sort of write the questions down that you had when watching them so that I could answer them now. So yes.
So I went to the doctor also, but I just from understanding the differences between static and dynamic libraries.
Okay.
Like, I understand like what they can do, but I just can't do it.
Okay. So let me pull up those slides. pointer. Okay, so this is, there are 4 steps in the compilation process. There's the preprocessor, there's the compiler, there's the assembler, and then at the output of the assembler, you basically have machine code for your program. Now, your machine code relies on, for example, the C library. So all that code that implements printf, well, you're not writing it. You're relying on it being written already, and then you would just copy in that code. Now, there's multiple ways of copying in libc functionality. You could, in the last step of the linker, so when you're calling GCC, the last step of GCC compilation is the linking step. Right at this step, you could say, you know what, I'm going to go into the file system, and there's a library of object code that implements printf. And it's in this thing, libc.a. What I'm going to do is I'm going to copy all of this code along with my code. So my code is in M.O and A.O. I'm going to copy all of this together and basically paste it all together into one binary and then emit P, which is my program. Now this program has everything it needs to run. The problem is that if everyone in this room has their program and statically links in libc.a, you have just bundles of libc all over the file system, right? And back in the day when we weren't in the terabytes of disk space range, we were like, that's a lot of space. I don't want that everywhere, especially on all my binaries. Like if you do an ls of user bin, you're like, wow, that's like 300 programs in there. If they each have a full copy of libc.a, that sort of sucks, right? So instead, modern, so here's a picture of it. So all your printf, your random, your A2I, all of this stuff this is an archiver. This is much like tar that you were using to submit your homeworks. It just pastes together all the files, the object files together, and emits a single libc.a. And that's the thing that you paste together with your object code from your program to emit this binary. So that's P. Statically linked, everything you need is in P, but horribly space inefficient, right? So, and then I go through a mechanism for creating your own libraries if you want to, if this is something that you find a need to do for yourself. So there's an example here that I walked through in the video that shows how you can create your own libraries, your own static libraries. But again, all programs use libc. You don't want to copy it in there. You have a large number of binaries with the same code in it. This is actually a security issue, because if you have library code and you find a bug in it, a security bug in it, all those programs that got statically compiled, you have to recompile all those programs for that security fix to make it in. That's difficult, right? And so we have the case right now where a lot of Android apps have statically compiled in this libpng library. It's an image rendering library. Turns out it's got a bug in it. It's got a security bug in it. And they're like, that's never going to get patched 100%. They have to wait for phones to die for that 2-year upgrade cycle to really patch this thing. So that, that's terrible, right? Like, so, but that's the trade-off, right? If it was dynamic and then I updated that dynamic library and pushed that one update out, all the apps get it that rely on that library. Okay, so that is static. Dynamic libraries they get at this issue. Instead of actually copying that library code into the binary, they're like, you know what? I'm going to point you into the file system. And then the code that you need is there in the file system. And then you create a binary that, rather than having that library code in there, has got links to the file system where that library code is. And then when you execute that dynamically linked library, the loader, the operating system, invokes a process, loads that binary into a memory space. The loader is like, oh, it relies on libc being in the memory space as well. I'm going to go into the file system where the compiler said that library code is, and I'm going to load those files into that process's memory address space. Yes?
So does that mean that if someone like packaged a .o file, an executable one, then you wouldn't, with a static library, you wouldn't be able to use like ltrace on it to see the functions it needs.
Exactly. So in fact, one of your first homework assignments for dynamically linked libraries, because you have your binary and it's loading code from the file system, you can actually hijack that load and inject like your own code into that execution. And so this is what this ltrace program does. Ltrace says, oh, you're using these dynamic library calls. I'm going to hook all of your dynamic library calls, and I'm going to spit out what those calls have going in, the arguments of all your calls. So that's one facility that you can do on dynamically linked binaries to pull out information. So in that particular, in fact, I'll show you this. I'll go through MetaCTF in a second here. But that's I think it's the second binary that you do. The second assignment is to capture all the library calls for dynamically linked binaries. And then you'll see, hey, look, there's a library call for strcomp, which is string compare. And look, there looks like there's a password going across. Well, that probably is the password. And then you'll see that that's how you solve that level. Just to get you the sort of the understanding of different ways software can be built and ways you can sort of get at the execution of software. If this were statically linked, that ltrace library, the ltrace tool can't capture any of that because all of your function calls are within that binary itself. So that's that. So let me finish finish off dynamic libraries. So in this case, this is the whole picture. You have your code, and then you can statically link certain code into your binary that you really want co-located. And then for other code that you want to get through the file system, you want multiple people to be able to load it at runtime, that's these shared object files. And so you saw in the previous slide, you saw libc.a. Those are for statically linked binaries. If you want to dynamically link libraries, they have a special version, these shared object versions, because you're sharing this library across multiple binaries on that system. Then you will dynamically link these libraries in, and then when you execute P in this box, there's this loader and linker, this dynamic loader and linker that gets executed to patch up this dynamic library with all the code in these .so files. And then when it's done, then you have a fully linked binary in memory, and then you can start a thread of execution, and then it will run the way you intended. Okay? Yeah.
I think I was reading on one slide that did you say modern operating systems will just have one copy of the layer library with multiple?
Yeah.
Okay.
So the actual final picture, yeah, it's this trick where, okay, I have 100 processes, and each one of them has loaded in libc.so into its memory space. Well, libc.so is exactly the same between all 100 processes running. And if you have a small amount of main memory on your processor, it's like, well, that makes no sense. So what the operating system does, is that it maps in one copy of libc.so in memory, and then it changes the virtual address tables of every single process to point to it. That's the real trick. And that's really deep. When you get into the next class, the operating systems class, you'll talk more about that at that level. But that's correct. The full picture. Yeah.
So two questions. One, so you can have both dynamic and statically linked libraries in the file, right?
Yes.
Do we have a timetable for what the CTF terminal is?
Oh, let me get to the CTF assignments. Let me finish questions, and then I'll get to the In fact, I'll do a walkthrough because I haven't really talked about the CTF homework at all. So what I'm going to do after this, I'm going to go through the CTF stuff, introduce it first, tell you what I'm looking for, and then so let's hold off on that, and I'll get to it. Yeah.
I just wanted to read a question. Mine's a separate one. When you're talking about processes, does it work fundamentally the same when you're doing programs that are executed on different architecture? So something like a GPU in comparison, do they have the same sort of like low-level processes that are interacting?
A GPU, my initial answer, I wouldn't know enough to be able to tell you. They're not running a full-on operating system. So what process separation there is mediated by some runtime, I would imagine. But I don't know enough. That we do have a GPU class here.
I don't realize that.
Yeah, that I would definitely recommend you guys take. I just don't know enough about it to give you a reasonable answer. Yes.
What is the target architecture for a link file?
You can ignore the target architecture. The target will be whatever CPU you're on. So by default, when you use make and you say, hey, invoke GCC to make this, it's going to use the native architecture that you're currently on.
Right, but when we're designing our make file for assignments,
Mhm.
some compiler options and stuff break. Like,
Which one?
like you can't use like input
Oh, okay. Dash M32 specifies an Intel 32-bit architecture. So there is this issue if you want to compile on an architecture that's different than what you currently have, there's these cross-compilation flags. So if you want to compile Android on a Linux machine that's running x86, so the Android is an ARM processor, there are special ARM tools that will allow you to compile and emit ARM architecture. Those options are there, but for everything that you're doing in this class, yeah, don't use dash M32. Don't use any flags I haven't taught you, and you'll be fine, basically.
in your examples.
Oh, there was? Okay, sorry. All right, let me
That's why I was asking.
let me go fix that. So there was dash M32. You're right. Dash M32.
That was
is
in
on.
the make file example thing because
Okay.
you're compiling on 32-bit architecture and you.
Okay, that's back when we had. I was teaching 32-bit x86 when most people had 64-bit already, and then I finally bit the bullet and switched to 64-bit. So yeah, I need to delete all that. But yeah, thanks for catching that. Good. All right. Yep.
I'm a little behind in my reading in B&O, but in the latest lecture of the system organization, you're doing all the object dumps and all those flags. Is there an easily condensed place where I can find all the object dumps and flags? Is that just something you have to go?
The man pages are, but I'm going to give you the key ones in the homeworks. So when we look at these binaries, I'm going to show you different ways of using object dump or readelf to pull apart the binary. And I think the one that you want is, there are two flags to object dump. There's the -D that says disassemble this file and give me the x86 code. And then there's the -S, which just says give me all the sections of the object dump. So those are the two for object dump. And then the readelf, I'll show you these things. And then when you actually go do your homework, you're going to actually be using them. And hopefully that's enough to get you what you need. Anything else from...
So like homework, we need those defining steps.
Yeah, the meta-CTF homeworks. So yeah, there's two homeworks actually. So the programming assignments are one thing, and the meta-CTF is what I'm referring to here. Those are getting you hands-on experience with these tools that are necessary to work on these systems. Yeah.
Are the binaries you download, are they confident you download binaries?
They are specific to a user, so they will only work on your account, but they should not change throughout the quarter. So the instance that's there, if you solve that binary and you can get that good job flagged, and in fact, I'll go through this again for those of you who don't know what I'm talking about. If you're able to get good job on locally and it doesn't work on the website, immediately let me know because that means I did something wrong. No, end of the quarter. So okay, so they're meant to be done as we go through the chapters. That's your ideal time to do all the levels because you can get it fast. You're only going to cost yourself time if you delay it, but I'm only going to look to see that they're done in their completion at the very end of the quarter. So if you feel like you're going to get slammed at the end of the quarter, definitely keep up. But if you feel like, oh, I'll just wait all the way till finals week, you're more than welcome to. That's fine as well. I don't recommend it. Yeah. Yeah, so typically these levels should take about, at most, 30 minutes each. You know, they're meant to be incremental in nature to sort of scaffold you up. But yeah.
So when I use actually I was gonna ask a question about the outbreak, but
I'll show you that. In fact, I'll solve a couple levels just to get you guys started.
I had a question about like how other languages link into the system, because obviously C is not the only programming language out there.
Mhm.
There's other languages that are completely separate. You have Java libraries like Clojure and stuff like that. And you also have like Haskell. Does Haskell and these other things compile down to C or C-like?
A lot of these things, and even C itself, could be compiled into this what they call a low-level virtual machine language. And then there is a native thing that is emulating the virtual machine. So a lot of them do that.
Okay.
And then some languages say, well, that's not good enough. Let me take that and go all the way down to machine code rather than run that layer.
Yeah, that's for like high efficiency.
Yeah, and it changes by the language. So yeah. Any other questions? A lot of these tools are specific to C, but like you can apply them. Like if, for example, Go, the Google's language, that'll compile down into object code, and then you can use object dump on that. It won't have the same sort of structure as a C, compiled C. Like GCC will emit different kinds of code for C than the Go compiler will emit for Go. Like the way it's using the x86 architecture might be different. Every compiler is going to generate its own style of machine code. But it's all machine code, so it's all x86. That's your API, so you can reverse engineer it. But everything I'm talking about to get you to be able to reverse engineer C x86 binaries is going to not be that useful for you when you're doing Go.
I was just kind of curious.
Yeah.
Is that virtual machine model good so that you don't have to update code for all of your different language compilers?
Yeah, that's one of the. Yeah, and that was the beauty of Java when it first came out. It's like, I'm going to compile to this Java bytecode, and then that bytecode is going to be portable across every single platform. And then I'm going to take an interpreter or build the Java runtime for every single platform that's out there. And that thing is going to change platform by platform, but the programmer doesn't see it. And then that runtime will execute your bytecode. So that's why this JRE, if you ever run Java, you need this Java runtime environment. That's what that is. Your runtime. All right. Anything else? Okay. Let me stop this. Okay. So for those of you who are really have fallen behind and don't think you can catch up with this course, in exceptional circumstances, if you come to me, I can negotiate an incomplete that would expire a week after the term. But you have to let me know ahead of time, just because of the result of the snow days. I'm trying to accommodate. I'm trying to be flexible to try and get as many people through the course as possible. But again, if you have difficulty doing the next assignment by next Thursday, the other thing that's happened is the late drop has been pushed out because of the snow day. So that's an option for you as well. Okay, so the groups I already talked about. The other thing I wanted to point you to, and I think some people found this, and it made their makefiles really easy, is the source code for all the class examples that I'm going to use. So you'll see on some of these slides, there's source code and then a pointer to where you can get that source code. This is on the website here. Right here, this class source code. It's a zip file. And if you go here, it's numbered based on the lecture by the slide number on the lecture. And if you open it, these are the C files that I'm using in the slides. And there's a makefile here that will build it. So if you extract these files on Linux Lab and then compile them there, you should be able to run all the examples that are in the slides. And so you'll see makefiles associated with all of these. Do a WordPad on that. So this is an example of building a target that's dependent on a C file and then the actual compilation step to build that. So yes.
Are we gonna get points out if our makefile doesn't contain it? So I went to your file, but for my makefile, I decided I don't need everything you have there.
Oh yeah, that's fine.
So we can
You can you're supposed to modify this and make it simpler. It's just so that the TA all the TA has to do to run your thing is to make and then execute. So that was the intent, to sort of make the grading uniform for the TA. As long as it works. He's actually going to, I don't know if the rubric is up, but that should be indicated in his rubric. Because I've told him for the makefile, it's just that there is one that automatically builds. But if it's not, if there's points being deducted because of, I don't know what else he would be looking for, then let me know and I'll work with him on that. Yeah. You could type, or you could have a make run, and the run would be just a target that only has the execution of your binary. That's correct. That's possible. Yes. If you wanted to, yeah. Good.
So for the makefile and the assignment, can you just do all?
This is going to be a really trivial makefile for your homework.
So
if that's what you're nervous about, yeah, it's supposed to be really trivial.
That's what I did, and then I looked at this and I was like,
Yeah, this is way more complex than you need. Yeah. So just to get you started with the idea of using make, and obviously you can, if you need more complex targets, there's a bevy of examples in this zip file. But yeah, this was just to get you started using it. So it's going to be really simple. You have one program, one file probably, and one target. So it's yeah, pretty much. Well, you should have your C file there because you don't want to remake it if your C file hasn't changed. But like that's pretty much it. There's going to be like, maybe 2 or 3 lines. Yeah.
when we turn the assignment stuff, like I was reading online, we want to have a directory with our name and then the class, and then it goes.
Yeah. So those.
So like when it goes into the class, can we split up the directories for the homework assignments for each one that we do? Or do we want them all stored?
You're going to be submitting these to separate Dropboxes. So I'll let the TA figure out. So you don't have to put the assignment name in the, like, you're talking about a directory path that has the assignment name in it?
Like, wherever it says, zip the files, and then you want to move it to a directory. Copy all the files and directories to be submitted
into a single file, yeah, a single directory. So this is your Odin ID would be here. These are your 3 files that you're going to submit, and then you would, in the upper directory, zip-r, john.zip. So you have to do the -r because this will recurse into that directory. You could actually do a zip-r, john.zip, and then just john, and it'll recursively add all these things. And if you don't see all 3 things added, that means your zip file is not going to have everything you need. Yeah.
So, okay, so I'm just trying.
Usually the directories have to do like CS201 and then your name, like one.
Like how it's up there. It's like
Oh, this doesn't matter because when you do the zip, it doesn't care about the path. Like when you
so it just
unzip,
matters that we zip the right file.
yeah, you're zipping a directory that's got all 3 files in it.
Okay,
Is
so
the big
It
issue.
has your name.
And it has your name.
See, I was looking up there. It was showing. I said to make a CS201 and then make a slide.
Oh, okay, yeah.
That was. I was like, all right. So I had made it, and I had already made a CS201
Okay.
file and put it there, and then
So
zip
this
them.
you'll have already. So yeah, whether or not there's a CS201 there doesn't matter.
Matters.
No.
As long as you zip the files that you need.
Yeah. So in your home directory, you could just have a John directory. So yeah, you John, and then zip-r on John, and it'll be fine. Because you're doing a relative path when you're doing a zip. So you see this is a relative path, and that's all that shows up. You don't get the whole path, the absolute path when you're doing a zip. Yes. I would prefer you do it on Linux just because that is how he's going to grade it. So if you can do everything, make sure everything runs on the Linux Lab machines. That is our standard grading platform.
What version?
1604, I believe, is what they're doing, what they're on. So, okay, so then